Hello everyone, welcome to the Tech Talk number 27. So we start sharp on time because we are live streaming here. And we have 3 talks today. The first one is from Karol about one platform, Anyscale. He's from Roche. Second presentation is from Thimo Koenig about AI. Well, it's basically AI, isn't it? Okay. And the third one is from Jonas about agentic engineering, basically AI again. And at 7:30 we have some snacks and drinks. As said, the session will be recorded and live streamed, so we'll publish the videos later on our YouTube channel. In case you want to follow and get notifications, feel free to scan. And our next events is again the Tech Talk Thursday on a Wednesday, and it will be on the 3rd of June. So in case you are not yet in our meetup group, feel free to join, and then you get a notification if we create new events. And if you want to be friends with me, here is my LinkedIn badge. That's already it from my side. Then handing over to Karol.
So, hello and welcome everyone. My name is Karol. I work in Roche as Principal Solution Engineer. I brought some colleagues with me. There is Dan, Marlena, and Alex today with me. Building medical products is not an easy task. The precision, the reliability, regulatory environments, similarly like building operating systems. For years, the industry has been doing this in a hard way. So we were building custom operating systems for every single device, reinventing the wheel, siloed teams, fragmented hardware. So we looked at this and said, there has to be a better way. You cannot build the future of healthcare on a fragmented foundation. You need a platform. Today, I'm going to share with you what we call one platform and a scale. We call it Roche Linux or just RLX. So, have you ever heard of Roche Linux before? Any of you? So let me explain. So this is not just an operating system. This is Linux distribution for medical products in Roche. I will talk later a little bit about architecture, but you can already see we use Debian as a foundation block for RLX. And the design of RLX is completely modular. We have more than 100 modules and many system flavors. So if you are deploying on physical instruments on-premise, in the cloud, in Kubernetes clusters, or developer environment, it is exactly the same platform. It has been a massive journey in engineering of RLX. Back in 2008, we started origins of RLX. We had a stack running on Windows OS, but as our machines got more advanced, PCR machines like this Cobas 6800 and 8800 and the LC96, we realized that the future is Linux. By 2018, we were bringing in Docker. By 2019, right before COVID changed the world, we migrated systems like Liat from Windows CE straight to Roche Linux. And now, looking at 2025 and 26, We are powering specialized hardware, such as SBX, which states sequencing by expansion, or digital pathology, and Kubernetes clusters. You may have heard about SBX device breaking a Guinness record last year. It did that in less than 4 hours. This is just incredible device. So let me tell you my story in how I started in Roche. I joined Roche back in 2019, just before COVID came. And I started from Liat project. And our mission was clear, to migrate from legacy Windows CE to Linux. And Roche Linux has been chosen as operating system. So we had to completely rebuild all the bootloaders, preloaders, kernel drivers, device tree, and so on, and everything for ARM architecture, which we did for the first time with Roche Linux. And we are doing this on 15-year-old device. There was just a single core CPU with just 256 megabytes of memory, and this device was performing PCR tests for influenza A or B, and later also for COVID. So to overcome those constraints and bring the project to market in just a couple of months, it was just a fascinating journey. So where can we use RLX? We can use it from ARM processors like this Colibri IMX6 board and virtual machines to massive data centers and sequencing instruments at global scale. So RLX is everywhere nowadays. The footprint is more than 30,000 Roche instruments using RLX in the field. What are the key features of our system? So it comes with Linux kernel, which can be custom made or hardened. It comes with long-term support from Debian because we base on Debian. It also comes with REST API, unified UI, security features like secure boot, disk encryption with TPM, also integrity check of the system, and this is all seamlessly integrated with Kubernetes cluster and can be also integrated with specialized hardware, FPGAs, GPUs, and so on. So let's look now at typical Roche lab. What do we see? We see entire ecosystem. We see various instruments connected with each other, working together. We have pre-analysis devices, we have analysis devices, and post-analysis devices. And in this environment, everything is regulated. The precision that is needed is absolute. We have a defined network, so every single device has its own IP address. It is a very controlled environment. And inside of many of these devices, acting as a brain, heartbeat, foundation, is Roche Linux. So now let me tell you about the real world. Typical labs look clean and perfect, but the deployment reality is sometimes different, and certain products are installed directly at hospitals, customer infrastructure, or in the customer network. And we call it the on-premise challenge. So imagine deploying critical medical software globally. For instance, in France, they may need ISO installer running on vSphere, or in Argentina, they may need VirtualBox running in Windows. And somewhere else, they are demanding full root access to perform security upgrades. So how do you manage this? You cannot. This complexity is infinite, unless you have a unified platform which can bridge the gap between global requirements and local realities. So to get closer to this platform, an operating system architecture needs to fundamentally shift from the rigid, monolithic, and device-specific builds. It has to embrace highly modular, decoupled, and API-driven design. So Let me talk a little bit about architecture. At the foundation, we have RLX running on Debian, but we didn't stop here. We built the RLX OSAL, which is our operating system abstraction layer. It is written in C++, and it handles all the events and procedures communicating via protobuf and 0MQ, now being replaced with gRPC, and we bridged this all the way up from the OSAL Python API to the RabbitMQ bridge up to actual applications which can run in Docker containers, Kubernetes pods, or just natively. And for the users, we have RLX web user interface built in Angular, which is our web frontend, which we will migrate to React soon. And this is communicating via WebSockets and REST API. So you see, this is also completely pluggable. These plugins can be implemented by projects themselves. It is full stack, it is scalable, and it just works. So RLX can come with web-based interface I was talking about. So in here, you can see capabilities like, for instance, system information, where you can change host name, you can change time zone or keyboard layout, and so on. You can do also resource monitoring in real time. You can also change network configuration, manage IP addresses, time synchronization, network settings. You can also do some software management, like software upgrades, like Kubernetes control center, system logs, and so on. This is just an example from one project, but believe me, there is more than that. So to deploy at scale, you cannot just write the code. You have to build an OS factory. So we transitioned from building custom OS images to the platform approach. And to achieve this, we use Molior, we use Aptly, and Spectra. So Aptly is Swiss Army knife for Debian repository management, which basically serves as Debian packages repository. Aptly and Molior are open source projects with way more contributions from community in Aptly. Molior, on the other hand, is primarily developed in Roche. And Molior is not just building Debian packages. It is also used to store information about projects, repositories, mirrors, and so on. And this is all required to be able to create reproducible environment for building Linux distribution. Spectra is a tool which we developed recently in-house, and this helps us to standardize, to catalog OS specifications, features, and also to generate the code and tests that are needed for creating final documentation. So our release workflow is automated. Usually triggers come in. It could be new features, new Debian release, or new security patches from Debian. And the source code lives in GitLab. So we store there all information about RLX packages, deployment configurations, and so on. It flows into our build agents in Molior, and then it is packaged into Aptly and deployed later to GitLab dedicated runners or our own runners, and then we store the artifacts in Artifactory. So in the end, our final deliverable is one RLX version. For example, we are now releasing version 2026.3 because it's March. So let's briefly talk about the RLX lifecycle and infrastructure. Because a platform is only as good as its ability to survive and adapt in the real world, how does a new version come to life? It always starts with a trigger. So the new version is usually triggered by a project request, Debian or security update. And then we enter into development phase, which leads to the production phase, and finally the product needs to be serviced for a certain time in the field. From the infrastructure perspective, we built a collection of RLX components in the form of Debian packages, which we deploy into specific types, such as Docker or ISO installer. Then we test, document, and deliver them to the market. And the device in the market usually needs remote access. It needs field service representative secure login. It has to be capable of upgrading. And usually, the lifetime of these instruments is like 10 years or more. I know this is quite a lot of information, so let's quickly go to the point. So what is the vision behind RLX? We are providing end-to-end secure and reliable Linux solutions that cover the whole development and product lifecycle of Roche products. So we removed the hurdles. We deliver, or try to deliver, high-quality, customizable OS configurations so developers can onboard rapidly. We embrace the power of co-creation and collaboration. We provide end-to-end OS delivery from the first check-in to the last update. And it all comes with fully automated documentation, is validation ready, has to be at any time, and always according to the workflow, which is design, develop, release, and update. So now let's look at the people on this screen. This is not an army of thousands. Nowadays, exactly 13 people are working on RLX and making Roche Linux happen. So we are based in Rotkreuz. This team manages currently 30 projects and ships 40 major releases a year. At the end of the day, all this technology, all these containers, and all these packages, it is all in service of one vision. We are doing now what patients need next. Thank you.
Are there any questions for Karol? Then we have a micro here.
Do you do any kernel developing, or you just, it's the main kernel from upstream?
The kernel.
Do you do
that
any
we use.
driver?
Sometimes it happens we have to do some drivers, but it's very rare, to be honest.
So it's just the upstream kernel, you don't do anything else?
Usually we try to use upstream kernel, from Debian, which is patched by Debian, but in most of the projects we need to go through the hardening phase and customization. So we minimize the kernel, we harden specific things in the kernel.
Just configuration, though, it's not any code changes.
You know, when we do hardening or we recompile, sometimes we have to do a little bit of changes in the kernel, to be honest, because we package in our way. We don't use Debian packaging.
You just answered my question. You don't use Debian packages. You don't use deb, apt. You use apt-y. So.
Yes, we do.
So my question is, how do you ensure immutability? How do you ensure immutability? How do you test end-to-end and ensure that what's deployed in the end is actually what you tested? Because for me, it's the biggest problem I have with Debian. I can't ensure that.
Do you mean how do we know what we installed is what we expected to be there, right?
Yes, exactly, to the bit.
Yes. That's a hard question. We use mirrors, right? We have aptly, we have Moyer, we can create mirrors, and we know what we have on the mirrors.
Mm-hmm.
So we know what we pull from, right? But if you build ISO installer, right, it's not always deterministic, right? There can be some bits changed if you rebuild the same ISO, right? So we are trying to test on what we build, what we delivered, right? We don't rebuild that later, usually. When it's released, then it's released, it's ready.
And you update using apt update, apt-get update? Or?
In the end, we built our own upgrade packages. We have our own mechanism to upgrade. So these are signed packages using in-house code signing mechanism with signature, which is Roche signature, specific for the project. We have our own mechanism to upgrade Kubernetes, so we can jump like 10 or more versions up if it's needed.
Okay.
Any other questions?
Sorry, I can ask, is this open source, like anybody can, or is it like licensed?
The license?
Is this licensed? Can I like purchase a license for your
I don't think so.
operating system?
You would need to come to Roche to play with this.
Okay, so this is it's not open source, it's for your client.
The open source part is just Molior and aptly, so feel free to use. I would be very pleased if we have more users, especially for Molior.
Okay, then let's say thank again for Karol and
Sorry. Now ready. Okay, hello everyone. Welcome to my talk. A few quirks about MCP. First of all, thanks Nine for having me again. Actually, it's my second time. I'm now officially a veteran, I guess. Just a few words about me. My name is Thimo Koenig. That's me, or that was me around 1 year ago, according to my iPhone. It's, you know, without any gray hairs and very fresh. I'm still 37 years old. Yeah. I'm a more or less active sportsman, so I try to running as much as I can, or doing some high intensity training. And in 2024, I founded together with a friend of mine the TechMinds. We are a more or less small company located in Germany and Switzerland. So this photo is taken in the Munich office. What are we going to do? So we are offering professional services in software engineering, especially in the field of cloud engineering and IoT. That was the beginning. And of course, when you found a company 1.5 years ago, you have to do AI as well. Otherwise, the AI will replace you probably soon. So, of course, due to that, we had a lot of AI topics internally at the very beginning. When we go to March last year, so roughly 1 year ago, we had an internal talk about a very shiny new protocol. It's called MCP, so Model Context Protocol. It was not super new anymore. It was already 5 months old, but but yeah, for us it was more or less new. We had our first proof of concept internally, and we talked with different customers about that. Some of our customers are from financial industries. They're not super happy to try new things out, but we found one customer who asked for an integration project. Actually, the request was, can we integrate our time tracking system, so part of the ERP, so in a way that I can chat with it. So he would like to ask which employee did forgot to track time last week or something like that. And we say, well, I mean, as a consultant, as a young company, you say, of course, yeah, we can definitely do that for you. So that was our first proof of concept project, and that's where the journey began. But let's maybe go step back. What is the MCP? It's, as I say, it's the Model Context Protocol. It's sometimes it was announced as USB-C for AI agents. Back then it was for LLMs, so USB-C for something. And the main idea behind that was that your LLM or your AI application become able to speak to the environment around, like external systems mainly. That was, in theory, it was possible before already, but it was a little bit harder. It was not standardized, and MCP, the protocol, just standardized the process how to communicate with the surrounding world. How they did that? Well, it's when you develop a protocol, it's probably mostly the same. You define some entities, give them a name, and define a way how they speak to each other. In MCP case, for today's talks especially, we will focus on MCP clients and MCP servers. Clients sitting on the host, and your client can be, for example, Claude. It was, I guess, the first client probably, because the protocol was invented by Anthropic. But it can also be your own custom software, or it can be Cursor or Visual Studio Code or whatever you have. The server part, on the other hand, is a thing you want to connect. So in our case, we had to write a server for the ERP system, or there are tons of servers for, I don't know, Slack, Notion, whatever you want. Probably also Kubernetes, I guess. According to the protocol description, the server can provide different things. And for us, for today, the most important thing is tools. A tool can be, for example, for our mental model, to make it a little bit easier, a REST endpoint can be a tool, for example. The server can also provide PDF files and things like that, but it's not super important for today. When the first protocol version came out, it was described how you can communicate, how client and server can communicate on your local PC, or on the same host, basically. But at the very bottom, they wrote, it's clear for us that it's not the future. We will offer remote, somehow, some kind of remote calls. So in the beginning, when we started the project, we just had standard input-output channels. During the lifetime of the project, they introduced the remote calls via JSON RPC over HTTP. And there has been some changes, but that's the main story. So we started locally, but luckily they introduced the other parts pretty soon. So as we are a tech talk, we will not look at the small version. We look a little bit on the full version. You have to understand the protocol a little bit, the sequence of the protocol. By the way, when you ask your LLM what is the worst topic you can talk about in a meetup, they will probably say, describe a protocol. But we will do it quickly to understand all that. So when you start your code locally on your laptop, the first thing that it's going to do, one of the first things it's going to do, is reading your MCP configuration files, it's iterating over each item, and starts the communication with each server. It's like a ping. In this case, it's not a ping, it's an initialized message. It's like an "Are you still online?" message. And it's responding with some metadata and say, yeah, I'm still there, everything is good, you can talk with me. And then your client is saying, okay, what can I do with you? What are you providing? And they say, well, here is a list of tools. That's the things I can do for you. And this example here, the tools my server is offering is the get weather tool. I guess it's more or less clear for what it is. Then that all happens before we send our first prompt. Now we send our first prompt and ask, okay, what is the weather? Well, what's the weather? What happens now is you start, you're sending these tools together, the list of tools together with your prompt to the LLM. When you have more tools, when you receive more tools before, then you send more tools to the LLM, of course. And the LLM is responding, well, that looks like, I mean, I see this prompt and this is a list of tools. I think you should call get weather. It makes sense for me. Then you say, okay. Then you execute the remote procedure call with to the get weather operation. The MCP server is responding with something. In our case, it's sunny and 22 degrees. And then again, you ask your LLM, well, now I got my response. It seems to be 22 degrees and it's sunny. And that was the original prompt. Am I done or should I do more? Sometimes, I mean, in a lot of cases, you have now some kind of a loop. In this case, it's easy enough that the LLM will probably say, hopefully, no, you're done, it's good. You can respond to the user with following a message. It's a little bit prettified now. It's a full sentence. It's 22 degrees and sunny, and the communication is done. So that's all we need to know for the Quirks today. There are some core messages. We had the initialization phase. We had the tool discovery with the list of tools. And we had the actual execution of the tool. That are the main things we need to remember for the Quirks. Now we come to the Quirks. Actually, Quirk is a hard word to pronounce every time, but yeah. The first Quirk, and it's not really a Quirk because it's a good thing, is authentication or authorization, to be honest. When we started with our first project, there was no specifications around that. So that's why, for our point of view, it was a Quirk, because it changed all the time. When you start now with such a project, it's good that it's there, of course. They changed a lot about the authorization specification in the MCP protocol. So coming from the no authorization authentication world through, well, now we have remote procedure calls to, we introduced OAuth 2.1, to we split the resource and authorization server to, well, now we are not sending any passwords anymore around. We use PKCE. It's not a Quirk, it's a good thing, but when all this happened while you develop your software, it's a little bit annoying, of course. Actually, what's interesting here is that the rise of MCP is strong enough that they enhanced the OAuth specifications a few times in the last few months. Looking in the, reading these RSCs or thinking about it a moment, it's somehow clear. The MCP protocol, I mean, they have very different goals. The MCP protocols would like to distribute as much as possible, while the security guys, try to reduce the or make it basically more secure. And it's mostly, well, a challenge between these two approaches. What they did is they found a way how different clients, like your software, your MCP client, becomes able to dynamically register on authorization servers. That was a little bit harder before. And before that, you had to register clients manually, and you got a client ID and a client secret. I mean, you probably all know that, and you can give the clients the credentials to your consumer. And they introduce now a process how all that can happen dynamically. That is cool. It's a cool thing. So yeah. Luckily, there was one draft in draft mode since 8 years. Now, thanks to AMCP, it's finalized. The next Quirk is token explosion. As you remember in the sequence diagram, when you start your client, you get a list of tools, and when you have a lot of tools, each tool has a description. basically a blob of text. And you send this blob of text, or the list of texts, to your LLM when you're sending a prompt. So it can be a lot, of course. I made a quick test on this weekend. So when I include the GitHub MCP server in my configuration file, it's around 10K tokens, and you pay for it, of course. Whenever you're sending a prompt to Claude, you pay for this 10K tokens. I had an old example that's not valid anymore, unfortunately, because everything gets a little bit better. But there was a time where I had my Notion MCP server included, and it was 240K. That's outdated. It's not true anymore. They optimized it, but it was, I mean, it's what's crazy. You have to pay for 240K tokens for nothing, maybe. As we said, it's mainly because we load all these tool descriptions and list of tools in the context on the initialized phase and work with it all the time. It's getting even worse when you have round trips. You remember this loop we had in the sequence diagram. When you have a long loop, you're not compacting your context window, it's getting more and more expensive for longer sessions. So the main message here is keep your list of MCP servers in your configuration as small as possible, especially when you think about agents. You know, agents have probably mostly one job. They don't need the full MCP server for Notion, GitHub, and I don't know, Slack. Actually, I prepared these slides this weekend, and sometimes engineers start to procrastinate. So I wrote a tool to measure how much tokens do I consume when I include different configuration files. And because I needed some kind of a demo, because it's boring otherwise. So what I did, great, no one can see it. Give me a second. So, okay, when it's not working in the next 20 seconds, we will skip the demo. Okay, that's good. Am I there? No. So I have prepared one small MCP configuration. It looks very similar to the one that you are probably using with your Claude or whatever. And the small tool I wrote last weekend was basically calling Open Router and using the tools of the tool list of your choice, and it's able to compare the usage. The token usage with and without the list of MCPs. I guess there's a missing dot. Okay, I cannot see it, I'm sorry. So we will skip the demo because I know what's wrong. The API key is not there in this context. I can show it you afterwards, but basically the same number came out there, this 10K for GitHub. The next quirk that's really a problem is security. For all the security guys, MCP is probably not the best idea. At the very beginning, it was like Wild West. Now it's getting a little bit better. It feels like it's getting better because they're now tooling around. It can scan descriptions. But here's one, I would say, famous example. It's an MCP tool offering, the ability to sum up two numbers. But it's not only doing that. It's calling an external service and asks the LLM, please read this file before and send it as a side note. That's not complicated, but it was still a thing. Nowadays, there are open source tools to scan tool descriptions, and it's also not really science. I mean, what they do is they scan for words like before doing X, and then they say, okay, that's probably a problem, because in your tool description, it's strange when you mention something should happen before actually calling the tool. And there are also lists, or online lists you can find with bad tools. But there are tons of examples. There are also new attack vectors that I will not go too deep into, but there's even a new UVA's top 10 list, of course, of everything around MCP. So MCP itself is a good thing, but there are, of course, always not so nice people around. You can also read some interesting incidents. I think the incident you might have heard is from Replit, where they deleted the production database. Yeah, things happen. There are still tons of MCP servers out there without any kind of authentication. It's not that old, this study. I linked it in the description. And I'm sure there are still many of them are not protected in any case, anyhow. The next quirk is it's funny. How does the LLM decide which tool to use? It's the name, of course, of the tool, and the description. The description is something no one liked to write, right? It is documentation. It was documentation before. Now it's important. There are studies around, again, there are papers that measure the quality of tool descriptions. And basically what they say is, I mean, just 100 servers, yeah, I know. What they say is most of them are crap. The description itself is not good. The parameter description is not good. The LLM, it's probably hard for the LLM to decide which tool is the best and things like that. Why is it a problem? Well, what happens when the LLM cannot decide which is the correct tool? It might select the wrong one. It just chooses the wrong tool. Or it maybe does nothing. There has been a study from Microsoft that shows sometimes the agent does nothing anymore because it's not sure what I should do now. All tools look similar. And for me, the worst case scenario is hallucination, when it does something. Deterministic behavior is still a problem, but hallucination around problems is for me the worst thing that can happen. Yeah, take care of your tool descriptions. The next quirk is about versioning. It's basically the same problem. Now, how do we version our MCP servers? What is the breaking change? That's the main question. What is the breaking change? For us as common developers, when we develop our REST APIs, it was somehow clear. You know, when you add, I don't know, a mandatory parameter. Yeah, okay, it's a breaking change. Nowadays, and what happens then when you do that? Well, the other engineers from the other team can come to you and say, "Well, guy, what are you doing? You break the API, blah blah blah." Okay, that's not good, but you can handle it somehow. When you work with LLMs, what they tend to do is, well, they find ways around the problem. They do something. It became even less deterministic. And even worse, the question again, what is a breaking change, is now completely different. Changing the description might be a breaking change. Changing the documentation of our tool is maybe a breaking change. That's scary and funny somehow. But yeah, anyway, we should treat now the description itself a little bit more like engineering artifacts. And one funny thing, maybe when we're talking about versioning, the versioning of the protocol itself is interesting. They use dates, which is maybe not a problem. Sometimes it becomes a problem when they introduce features in one version and remove it in another version. And the only thing that changes is the date. For you, it's a totally breaking change. Functionality removed. Sorry, it's totally breaking. There's a lot of discussions to change the version schema of MCP itself. The last quirk is we all, I mean, I'm not sure of all, but at least me, I'm learning a lot on public available content like YouTube, YouTube Academy. I'm a big fan of YouTube Academy. And there are tons of videos about MCP, how you can set up your own server, your own client, whatever. There's a big difference between all these videos and bringing it in a bigger company, like an enterprise. In enterprises, when you come up with such an idea in a meeting, there are probably, I don't know, the enterprise architect speaking about, wow, what's the catalog, where's the API gateway, where are my policies, what is weight limiting quotas, auditing, token tracking costs, for example, of course, cost is an important factor, any kind of data governance, and 1,000 other things. And when you're reading this list, you might think, hey, I've seen that before. Some years ago, when we introduced REST services, we had exactly the same problem. And some tools around there observed that as well. Some smart API gateways, for example, like Kong, or in our case, we use a lot Gravity. And I cannot show the live demo because, for the sake of time, sorry. And what they did basically was, well, they have these functionalities already in their tools, and they adapt a little bit for MCP. It's not so different, but before introducing tons of MCP servers in your company, you might want to think about such topics. I will skip my demo flow, sorry. So, and when we now we have all these quirks, all these problems, and it's, as a consultant, it's always good not come only with your problems, also come with solutions. It's one of the first things you learn. So we had some kind of a mental model. The name is, of course, inspired by the REST maturity model. I call it MCP maturity model. Let's do a quick version of it. So at the very beginning, we had no MCPs, which means we had basically no of these problems we talked today about. Then someone came to the idea, well, let's auto-generate MCP servers. We take our OpenAPI specification, drop it in a generator, and voila, we have a list of MCP servers. This, of course, produced most of our problems because now we have MCP servers. What we usually do then is analyzing, the usage of these APIs and starting to consolidate the complete interface a little bit. So what you typically have at the beginning is one MCP tool per REST endpoint, for example, and most of the time you end up with, you have, I don't know, 4 or 5 REST calls behind one tool, things like that. And of course, you start writing better documentation, better tool description, and you treat your description as engineering artifacts. So changes, as I said, in the description might break your software. And at the very end, you have tools like Gravity or like Kong or whatever. There are probably also other tools around that makes them a little bit enterprise ready. So, little bit of the meta layer. MCP is, when I wrote this slide, this was a de facto standard. Now Tom said in the very beginning it's outdated already. Why are you talking about MCPs and not about skills? Sorry, next time maybe. It was handed over to the Linux Foundation, who invented the Agentic AI Foundation with some other companies together. And of course, the marketing machine is already running. So there are already conferences just about MCP. If you want, you can go to Amsterdam this year. Yeah, interesting to see. Let's say in that way. Oh, I'm sorry. Yeah, sorry. I'm there. Okay, very good. So takeaways, evaluate gateways or some kind of professional software before introducing MCPs around your company. This maturity model, or maybe just the ideas out of them, is maybe a good starting point. And I would recommend to aim for level 3, which is respect your descriptions a little bit more. It's really, we have seen it. It can become a problem. And think about security. That's it. Thank you very much.
Do we have questions for Thimo?
Hi. My question is, since the last time you worked with MCP, since last year, how has the use cases or like client needs changed over time, and how do you foresee that to change in the next couple of months or year?
It became somehow normal. I think the biggest change was that it's not a joke. A bank contacted us and asked for MCP integration. That was totally different than 12 months back. And the ecosystem around MCP is much bigger, like the security scanning features, for example. And the thing that impressed me the most was the speed where companies like Kong or Gravity were able to adapt their software to be able to handle MCPs. I mean, it took, I don't know, maybe 6 months. It was a big software before already, so that was impressive somehow. So I would say the tooling and the adaptation on client side.
Other questions?
What's happening on? Hello. Okay. What's happening on the regulation front? How long till the government gets involved? We have this big blow up last week about Claude and the Pentagon and weapons that kill, and it's all remote. And
yeah, I mean, maybe not only an MCP question, because MCP is now everyone is able to use MCP. It's a protocol. For everything else, yeah, we have customers who have only on-prem software, and that's become more and more a problem with the huge models. Some of them, I mean, at least one of them, invested a lot of money in NVIDIA graphic cards, of course, to host all the stuff on offline or on-prem. But it's, yeah, I would say it's much easier when you're not limited to that. Otherwise, you have to rebuild a lot of things, and you have to spend a lot of money for that. Yeah. So what should I say? It's a problem.
So last question. Any other one? No one? Okay, then thank you very much.
Welcome.
Yeah. The question was if I'm good and if I'm ready. I think I'm good. I'm not sure if I'm ready. So long story short, this will be a very interesting talk because I do a lot of freestyle live demo. And one funny thing about this whole AI agentic thing is that it's not deterministic. So I have no idea if what I want to do in 20 minutes or 15 minutes demo will work. So my goal of the talk is to give you some inspiration and some kind of like glimpses in what you could maybe want to try and what you maybe can combine to work with those things. It's not a comprehensive talk about all the topics because we have only 30 minutes and that's basically it. I want to focus on some DevOps topics, some platform engineering topics, so we stay in this area a bit, but where we go exactly, we'll see. I'm Jonas, I'm from Let's Boot. I do a lot of platform engineering, also build some software and do a lot of teaching. And it's interesting, like about 2.5 years ago, I think, maybe it was 2 years ago, I was already like, hey, we have this AI coding, there was this GPT engineer and you could write your first software, and I had the first trainers who were like, hey, we have to teach that. And I was already using it to kind of reformat some old training material. And that was back in the days, do you remember when you had a context window of like 8,000 tokens? It was like the hard times when you really had to think about what you do. And I was like, probably not yet, not ready yet. And then we did one course at Basel Hack, a hackathon, like a warm-up, like a bit of kind of vibe coding with copy-pasting and some kind of like first of these tools. Does anybody remember GPT Engineer? That was kind of like one of the first projects where you had a Git repo and you wrote some lines in a markdown file, and then you triggered some Python script and it tried its best with this kind of like, what was it? GPT 3.5 or something crazy. If we look at this today, we couldn't even imagine how we could do anything with this kind of model. And then it tried to somehow, with the 8,000 tokens, build something. So I said, okay, this is maybe fun for a hackathon, but we can't teach that to our customers because there's just too many things it's struggling to do, and too many things you have to do to give it any value. So kind of like the effort you put in and the value you get out is this thing. And then like 1.5 years ago, we had a combination of a trainer telling me, hey, we should look into that more to do actually training. I was already using it for myself a lot. And we had a customer who said like, can we do a training around DevSecOps with AI? Just one day, just trying it out. And then he showed me some tools, and there was a big change happening then. And the big change was what I really want to tell anybody who works with that. And the big change is the way you work with the tools, the way you work with the model, going from kind of like giving it a question, hoping for the perfect result, to having this kind of like interactive back and forth, like peer programming. Like if you do peer programming and you sit together at a keyboard and you talk to each other and you think about what's the plan, and somebody tries something and builds something and the other person is watching. In this case, it's also not like you're sending some minimal prompt, copy some code somewhere else, and some other person has to figure out the best answer and sends it back to you. The other person, if we would talk about the model like a person, also sits with you at the keyboard. So you give the other person the option to try out something, to look up something, and to also verify the assumption that the other person does. And you look what the other person does, and you interact and say, stop, what are you trying? What are we really trying? Do we want to go a step back? And this is kind of this agentic workflow, which then really changed for us the idea of being able to teach something that we think can benefit most engineers, be it software engineers or platform engineers or whatever you want to call yourself, in their daily work. Which means you try to have a peer programming situation where you have the model on one side, which doesn't do anything if it's not called, because in the end it's just like a huge amount of numbers in memory. But you have this agentic tool in the middle, and you're communicating through that with the AI, and the AI gets the chance to also try out things on a system, which you can either stop or allow or interact or interfere or go back. This is kind of the cycle we recommend. Make sense? Okay, let's see what we can do. So, when I tell somebody to start or look into agentic engineering, I usually recommend or recommended, this also changes over the weeks, an open source tool which is called Klein. It's just a VS Code extension, but it actually really doesn't matter what you try, what you use, as long as it can integrate with the environment you need, as long as you can stand behind the organization that is behind the tool, and as long as it provides you the workflow. I personally like Klein because it was one of the first tools which had this kind of like agentic interaction integrated in the IDE, very powerful and also very transparent about what it's doing. So if we look at Klein, we have a prompt, a chat window. There is nothing new. And we have the option to choose models, and we have also the option to choose model provider. That's also a reason why I recommend Klein and why I was quite hesitant to switch to Claude Code, which I now have to admit is way more powerful, especially with its ecosystem. But a long time I was like, I'm not going into Claude Code because it forces me to have a subscription with a specific company. And I want to be able to choose the model, and I want to be able to choose the model provider, depending on the task I have, which is a cost question, but it's also a trust question, but it's also an ability question and a performance question. So this is one choice. Now this changed in the last weeks that now you can use Claude Code, for example, which you probably heard of, which I also will do a short demo. You can use Claude Code with most providers. There is still some kind of like cases which are tricky, and they're like very strong competitors to Claude Code actually quite a lot, because what it does is not that magical. It's just very good at it. The way they did it is really good at it, like open code and so on. So when we work with an agentic tool, we can give it a task and tell it something crazy. Let's say, build a mermaid diagram generator using Alpine.js and a minimal Go backend. The open router token is in lab open router token, I hope. And then we can basically say, let's allow it to do anything, and let's just YOLO away. That's all the YouTube videos you see out there. And now it starts to try its best to to do whatever I want it to do, or whatever it thinks I want to do. And as you know from those YouTube videos, it's actually quite good at it. I mean, Claude Code is a bit better than those YouTube, than Klein, but still it's quite good at it. The question is just, is this the way we would want to build it? Is this the way we would do it? Would we send like one WhatsApp message somewhere else to some engineer or team of engineers and just have them do something without talking to us and hoping for, sorry, I missed here a checkbox box. Here, this one I missed, sorry. That's not what we would do. What we would do is actually, and you will be surprised how good it is, but I will cancel it now because that's actually not the point of the talk. What we would do is we would actually tell it, hey, let's first talk together what we want to do. And let's first, I hope I don't destroy anything. Okay. It's like I'm Git. Okay, let's first make a plan. So the hardest part for the model usually is, although there are now more and more better methods to get them to do that, is the hardest part for the model is not to just come up with a solution. Models want to directly come up with a solution, but that's because that's what they are trained for. So the hard part for the model is usually to make it go a step back and say, okay, let's first think about what we want to do. Let's validate what you want to do, and let's think about the tools we need to build that. And in my previous company, we had a strategy because back then it was quite hard to find engineers, especially for us as a like 20 engineer company in Basel. So we had a lot of junior engineers, and that was the same topic. Like usually, if you have a senior engineer, it's not the general. Some junior engineers are super good, and some senior engineers are very chaotic. But like in general, if you don't have that much experience, you try to do too much without thinking too little about what you want to do. And if you're more senior, you're more like structured and thinking, okay, what tools do I want to work with? And what's the workflow I want to go after? What do I need to decide? What do I need to know? And when I started to work with the model, it suddenly reminded me of me coaching or working with those junior engineers. The only difference is the model knows a crazy amount of random stuff. Some of it is very valuable, and some of it is really not valuable because it's more distracting than actually helping. And that's a big difference. The juniors we had usually didn't know like every programming language to some crazy level. But still, like I suddenly realized like it's actually quite similar as we started to work with those junior engineers, because we had the issue, we had only a few senior engineers who really knew like how to build stuff, and way more junior engineers who had time. So what do you need to do? You need to kind of like have time slots, sit together with them, make a plan, think with them about like what's the amount of work you can usefully do, so I have a chance to check what you did, and we can talk about your next step. And this is basically the methodology which I think is something you can transfer to the model very well. So what you can say is you can say, let's work on a plan to build a mermaid diagram generator using Alpine JS and Go backend. And then the model should try to think about what we build, should understand the environment, and should ask me questions and propose a plan and interact with me about what we want to do. That's basically the idea of this planning stage. So now you see this magical thinking thing here, which basically just says that that you told the model to basically have a certain amount of tokens it can use to reflect on what it wants to do and give it some kind of like extra runway of talking to itself. That's kind of like the easiest way I try to explain it. But I technically don't fully understand the difference between the thinking and the non-thinking thing. And now we can have a plan and we can talk about this model, this strategy. And then we suddenly say like, okay, but is this the pattern we want to use? I prefer to put the front end into a separate subfolder, and so we can treat it as its own project and deploy it separately. I need a way to configure the front end to know where the back end is. The back end needs to use OpenRouter for now, and I'll provide the OpenRouter token in a environment variable. So I can give it more input. I can see, okay, it does something with a structure that I don't prefer. I prefer a different structure. I see it maybe has some assumption or some information it just doesn't know that I want to have, because I usually don't think about everything at the beginning. And then it will basically adjust its plan. Now, that's a funny thing. I'm so thankful for this example. That's really nice. That's not something you will have to fight with models a lot. Is models are always out of date. Does anybody know why the model is always out of date? Outdated. Why is the knowledge of the model always outdated? Because the things that the model so-called knows, we call it know it. The information that the model reflects in this big fog of math of numbers can only be the information that it was fed at the time of training. It can't be anything newer. So if you try to build anything with using other models, you will sometimes really struggle and fight with the model to use actually to refer to a newer other model, because it just says that doesn't exist. I don't know of that. So this is the first point where we want to give the model a tool. So far, by the way, this is something I jumped over in my hurry. I just enabled these kind of tools, which is kind of like reading files, reading project files, edit project files, running all kind of commands, and this is the next topic, using MCP server. I will not talk much about MCP server because I think you already heard about it, but I want to now verify that it actually uses a reasonably new model. So I will tell it, I think that's off, there is a newer model. Please verify newest model versions for OpenAI. I don't like OpenAI. Let's take something else. Should we use Grok? No, that's not better. Oh, who could we use? Okay, let's go with the company who doesn't want to be evil. Newest model version for Gemini. And now let's see what it does. Let's see what it does. Let's see if it comes up with what it should do. Okay, it did it. So what it did now, it called an MCP server, which exposes web search to the model. By the way, if we talk about these kind of things in very simple terms, we like to say the model calls something. Probably you already talked about that in the MCP talk, but the model can't do anything. All we do here is string concatenation. We put together text, we throw it at the model, we get text from the model back, and we look at it. And if in that response from the model is some specially formatted text, we say, oh, this is something it wants to do, and that's where then the MCP servers come in. So it now got this information, and now we can basically go and say, yeah, let's go with, let's not risk it. And it's actually not even completely up to date, because there is a Gemini 3.1. So, but I will not waste time now. I will say, okay, let's use this. Also, I need Docker files to build containers, and also I need GitLab CI YAML files to build and push the containers to my registry. Here I got an example how to do that. Let me see what I will use. Da-da-dum. Okay. Let's go, I think this one. So I tell it how we usually build containers at our organization, and then I tell it use this. I'm not sure if I can actually refer it. I think it will not accept this. I will. Ah, can I do this? No, but I can say it will look it up. Okay, so let's do that. Now, what I just did is I told it to search something to verify that the information is correct, that it was assuming. I chose from what it suggested, and then I told it some more information about what I wanted to do, and I referenced an example that we in our organizations have, which, by the way, makes sense. It's crazy to go to a model and just tell it in an empty space, just build something for an organization, especially if you're not like a startup where you're one person sitting in a Starbucks with your laptop and, I don't know, one serverless application where you can decide anything on your own. Usually that's not this kind of like empty space that you're moving in. You're moving in an organization with a lot of dependencies, which are organizational, which are technical. And what do you do with a junior engineer if you want them to not just build the vanilla Node.js task list? You go and look, where do we have it? Where is it documented? Where do we have an example how to do that? So that's the same thing I tell it, is basically I tell it, look at an example that I have and understand our structure and understand how we work. Now what I will do now is I will say, because I don't want to waste too much time on that, of course, we want to do DevOps, DevSecOps. We don't have enough time to do a lot of sec, is I want to tell it, okay, let's write down that plan. Let's write that down as a plan in plan.md. I hope that works. So I switch to act and I tell it this. Now if somebody saw like, hey, I will never do a training at this company because he says the AI is allowed to read all files and is allowed to execute all commands, you would probably be right if this would be my local machine. But this is not my local machine. This is a lab environment. It's similar to a dev container. It is its own isolated environment with its own development Kubernetes cluster, with all the things that I need to efficiently engineer software and do DevOps and test things. It has its own, like Argo CD, it has its own Git repo. Obviously, there is still ways to use this to do something malicious, of course, but at least it should not be able to destroy my production database of my production GitLab for our 3,220 something alumni. Okay, so now we're in this peer programming mode. Did you see something? I told it to do the plan, to write out the plan, and now suddenly it starts to write Go. And I'm like, stop, no. Why are you writing Go? I didn't tell you to write Go. I told you to write the plan. That's this peer programming situation. Now I take over the keyboard and say, give me a second, wait, let's first look at the plan. Let's maybe just edit this file, because do it in here is maybe annoying. So I showed how to make it search the web. I showed how they can use tools. So what we did now was, by the way, not just like prompt, answer. It was prompt. The AI did some stuff, and then it gave me a suggestion, and then I told it how to continue. And we even used MCP servers, and we used context. We told it to check files. So, by the way, this is also very nice. You can check how much context you have. You have also breakpoints where you can jump back. But now I want to close this tool, and I want to say, it's not a conventional commit. Excuse the time. So doing what I just did feels so good. Git-u. Keep what is valuable and being able to throw away what you don't need. Keep what is valuable from the conversation and reset the interaction point you have with the model. It's like taking a break. Let's take a break. Let's take a coffee. Talk about it maybe at the coffee. Come back, look at the flip chart again. And don't try to keep everything in your mind. So now I want to switch tools. Now I'm in Claude Code. If you use Klein, Claude Code, OpenClaude, GitHub Copilot agent, it does not matter. I really do not care about the tool. And also the models, they all converge to the same thing. Like they have a little bit priority on that, or they have a little bit priority on that. This one is a little bit better at that. This is a bit cheaper. This is a bit or let's say this is waste. They are willing to waste more money. they are willing to waste less money on tokens or GPUs, and so on. So this is kind of like this spectrum, and this tool is maybe a little bit better at that. This tool is like doing sub-agents. So 2 weeks later, this tool is doing the same. So finding a tool you find comfortable with and learning the patterns that make it work. That's the thing you want to do. So now I'm in another tool, Clean Slate. It only knows what is written in the default information that the model gets. Like the information that it's getting put into the context, meaning that long bunch of text that's thrown into it. And now I will tell it, we already have a plan. Sorry. Start sub-agents to implement front-end and back-end in parallel. And now I switch the tool, and I kept what is valuable, which is our plan that we created with the other tool. And this tool is able to spawn multiple of those kind of like agentic loops, and allows me to basically have more code generated in a shorter time to have more work reviewing it. So I see I'm getting slowly out of time. And this is really a very risky talk. Okay, so now it didn't know something, so it created this GitLab CI YAML, and it has to use the demo GitLab CI YAML, and then we just hope it works, because what I will do now is a very bold move. I will give it one more chance. Yeah, you see, this is the point. Did you know this meme where somebody is with a coffee telling via voice to text the AI to change the distance between two divs to increase it by 5 pixels? This is exactly that example. I'm now discussing with the AI, which is not understanding me, that I actually wanted to use the demo GitLab CI, because GitLab CI is not considered in our project. Instead of saying, forget about it, I will just do this, and I just save me like 5 arguments until it gets what I want. So I hope that works. And this is the reason the model is kind of right, because it does not know why demo GitLab CI should be used. It just sees that there is a job in there. And now, let's continue, and let's go git ACP YOLO. So now we're not in the agentic professional engineering area anymore, but that's like 30 minutes. Now we're like, that's why I call it YOLO. And now let's just hope it does something. Yeah, that's also something it can't know, which is it's tech talk. So this is the question about management. But why do we need engineer? I can tell it to program that I don't know, dog food organizer app, and you're like, yes, but that runs on your local laptop at home, and not in our data center with like 30 years of legacy and dependencies. Right. Okay. Okay. So now it builds those containers. And because my time is up, I will not fix that. No. And the reason is really simple, because the path, of course, is wrong. But you see what I mean? It's about the context you provide, the tool you use, the workflow you have, and understanding the patterns that make things work, and understanding the issues the models and the tooling have, which lead to bad outcomes. That's kind of, and I really want to fix it, but I know I don't have enough time. So let's go back. So the most important things is small steps, safe environment, and this kind of like peer programming. approach of having this kind of like interactive things, steps, and finding kind of like the optimum point for your project, like project and knowledge to be effective and efficient. Because using those tools and the models and those processes is very dependent of what you want to do, what your knowledge is, where you want to go, and the tooling and environment you were able to use. So that's it.
Are there any questions for?
If you wanted to expand what you were doing with real peer programming in the sense that you wanted a colleague to join you working together on this, how would you do it? Do you both sit next to your laptop, or is there some way of distributing this multiple console GUI so more than one real person like yourself could do it, especially if you're not necessarily in the same area?
Ah, okay. So that's actual peer programming with like actual two humans building on that.
Yes, with your AI buddies and all this.
That's an interesting question. I mean, at the end, you need. I'm now actually working way more with Claude Code than with Klein. So I don't know. I'm a Unix guy. So I started Unix like in 1998. I think Screen or Tmox, and then you basically can use the same interface with two.
So the tool doesn't know that there's two of you. You're sort of.
I don't know if it needs to know. I mean, it would not be that hard to build that actually. I mean, I played around with OpenClaw a little bit. So if you want to go really crazy, you could use OpenClaw and just chat both with it. But I think the problem is that the answers would not be the same. Yeah. So I think actually just going a step back and say, I mean, it's at the end just a tool. It's a tool you write text in. It does something, hopefully the thing you want, and it shows you something, like any other software too. It just does way more and way more unpredictable stuff. So probably isn't there like also a VS Code sharing tool where you can kind of like work in the same VS Code? But probably it's just the same files. So really, really simple approach would be probably SSH into the same lab environment, and then just use Tmox or Screen in the same Claude Code and start a whatever Google Meet Zoom session. Yeah.
But it's definitely sort of a kludge. It's not really that it knows multiple
yeah.
users and stuff.
Yeah. I mean, you could do that. I don't know how you could do that. I mean, with OpenClaw, I played around a little bit. You could do that. You can use OpenClaw. The problem with the OpenClaw is it's not really made for software engineering. So the problem with OpenClaw, it's quite intransparent about what it does. And that's why I really like, by the way, to start with Klein and not with Claude Code, because Claude Code is also sometimes quite too fast doing stuff. So if I actually teach the things, we have like 2 days, and then I make the engineers disable all the automatic stuff. So each step the AI does, they need to confirm. And usually also they see the diff of the changes, and they see, oh, this line it changed doesn't make sense, so they can interfere. But to show that in a demo would just take a little bit longer. Yeah.
Thank you.
Yeah.
Yeah, you've shown quite well that even if the AI does a lot of the heavy lifting, you need to understand a lot of the technology and the underlying mechanics and technologies that you're using. Do you think that's going to stay for a while, that knowledge, that we still need that in order to code, or is that going away and this is just like the next few months where we still need to know all this?
I actually don't know. But I think imagine we want to build a house. I don't know how to build a house. I think I know how a house should be, so I like it. But probably if I would draw it and have some company just building the house for me with my drawings, I don't know how nice of a house it is. It's a really tricky question. It's a tricky question. I don't know. I think for some areas it will change extremely fast, and for some areas it won't, and it will probably be depending on how high is the chance of a desired output versus the effort of giving it the right input. So some software engineering field, like probably, I mean, there is always this stupid image with like, back then we had people who were punching this kind of like, how is it called again, the paper with the holes and stuff. So I think there are software engineering areas which will change very much, and there are some which won't change that much. But the good thing is, as we all know, the customers want way more than we already can do. And we're pretty sure they will want even more if they see that we are faster and that we can provide more. So I'm somehow confident. I'm scared of other things more than going out of work. I'm more scared of like stuff being built too fast and rolled out too quickly because management sees, or what, it's not only management, but let's say it's also engineers. If you build stuff very quickly and you build so much stuff that you have no idea what it does because it's just too much and it seems to work very well, and you bring it on the market, it's maybe okay if it's the next, okay, that's a stupid example, but if it's the next dating app, it's maybe not the worst case. But if it's like some, I don't know, some diagnostic software that steers whatever, a medical device, it's probably a risky thing, yeah. So I'm more afraid of, I'm not afraid of going out of work, I'm more afraid of stuff going very wrong because stuff is built too fast, yeah.
Okay, I'd say that's enough for today. Thank you very much for attending. And thanks for all the speakers, and enjoy the food. Have a nice evening.
Thank you.